Okay, gauge pressure and absolute pressure. Well, first of all, let's talk about a pressure gauge. Whoopsie. Pressure gauge is simply a device that measures the pressure in a fluid. You probably use a pressure gauge to check the air pressure in your tires. But here's something you might not have known. Pressure gauges don't read the actual pressure. They read something called gauge pressure. And here's how it basically works. Whoopsie. Gauge pressure, P sub gauge, is equal to the actual pressure minus whatever the atmospheric pressure is there. And the actual pressure is called the absolute pressure. And it's given the symbol P, ABS, P absolute. So basically, the gauge pressure equals the absolute pressure minus the atmospheric pressure. And just keep in mind that the absolute pressure is the actual pressure that the fluid exerts, on its surroundings. Let's look at an example. Air pressure in tires. Normally, when you go to check the air pressure in tires, the gauge will tell you that the pressure is 32 pounds per square inch. Another way of saying 32 pounds per square inch, 32 psi, pounds per square inch. That's not the actual pressure of the air inside the tire. If you wanted to calculate the actual pressure, you'd have to use the relationship, the gauge pressure equals the absolute pressure minus the atmospheric pressure. So the gauge told us that the pressure inside that tire was 32 psi. The absolute pressure is what we're looking for. And atmospheric pressure, I mentioned earlier on, is equal to 15 psi. So if you rearrange that, the actual pressure that the air puts on the inside surfaces of the tire and the rim is, what's that going to be? 47 psi. Let's go back and look at this example again. Basically, let's call this point right here P1. And basically, at point 1, let's, recall that we said that the pressure there was equal to 1 times 10 to the 5th pascals. Yes? That was actually atmospheric pressure. That's the actual pressure at that point 1. So what would the gauge pressure be at point 1? Well, we know that gauge pressure is equal to the absolute pressure, the actual pressure, minus the atmospheric pressure. So if we're looking for the gauge pressure at that top point of the water, it's the absolute pressure. Well, what's the actual pressure there? 1 times 10 to the 5th pascals, minus atmospheric pressure, which is 1 times 10 to the 5th pascals. So what is the gauge pressure at that top point? 0. So at this top point right here, the absolute pressure is 1 times 10 to the 5th pascals. The atmospheric pressure. But the gauge pressure, if you had a barometer, which also measures pressure, the gauge pressure would read 0 pascals. Okay, let's consider the lower point down here. Whoopsie. Okay, at this lower point down here, we determine, I'm going to call that point 2. We determine that the pressure at point 2 is equal to, anyone have that? Look back in your notes. $155,000 pascals. That's the absolute pressure down there, the actual pressure. What is the gauge pressure at that lower point? Well, gauge pressure equals the absolute pressure minus whatever the atmospheric pressure is. So, whoopsie. The gauge pressure is going to be equal to the absolute pressure of 155,000 pascals minus atmospheric pressure, which is 1 times 10 to the 5th, or 100,000 pascals. So the gauge pressure at that lower point is going to be 55,000 hectopascals. So here's another thing I want to point out, folks. With that depth formula, P2 equals P1 plus rho GH. If you substitute in here the absolute pressure of that particular location, then what you end up getting over here is the absolute pressure of the other point. On the other hand, if over here you substitute in here the gauge pressure and crunch out your formula, then over here you end up getting the gauge pressure at the lower point. This formula works whether you're using absolute pressures or gauge pressures, but you have to be consistent. If this is gauge pressure, this should be gauge pressure. If this is absolute pressure, this is absolute pressure. Now, an interesting thing is, if you're doing gauge pressure and P1 happens to be atmospheric pressure, then what would P1 here become? What is the gauge pressure where the actual pressure is atmospheric pressure? That's right, 0. So basically, P2, the gauge pressure, in that case, would equal rho GH. So basically, the formula P2 equals P1 plus rho GH just simplifies the P2 equals rho GH if you're figuring out the gauge pressure and your top point pressure is equal to 0 gauge pressure for atmospheric pressure.